1, 2. Good evening. This is VK3 EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast. Coming to you from the studios of VK3 CSJ in Narre Warren South. Broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also on the Melbourne television repeater VK3 RTV digital channel 1, and via the two streams on my YouTube channel. Just search for VK3 CSJ, VK3 Charlie Sierra Juliet on YouTube. Look for the live indication, and also the Discord channel on my HD stream there. If you're not registered on, or if you're not logged into Discord, as I suggest every week, to register on Discord. It's just a matter of registering and doing applying for an account, or doing an account. There's no money involved. And on my QRZ page, VK3CSJ and VK3EKHQRZ.com pages, I provide a universal link of sorts, which will get you to the astronomy chat room, which is where you'll find the HD video stream. Hang on a sec, I've got dual audio happening here. Hang on a sec, this is a problem with my camera. I need to get this fixed up. Hang on a sec. It's because that's on. Turn that off. Alright, that's better. Sorry about that. I have an internal microphone inside the camera, and I need to actually turn that off, or else there'll be a delay happening. And I think I've got that sorted out, looking at vMix. So anyway, we're back here again. I think everything's all right with the streams and that. There is an email address, vk3ekh@gmail.com, vk3ekh@gmail.com. Signal reports and audio reports and whatever reports are welcome. And let me just check that I have got the inbox going. Yes, I do. Not a problem. So I'm monitoring the inbox there. All right, we have a few things tonight. I should be able to squeeze it in all under 60 minutes. We have just a couple of articles, but one article particularly on a professional radio astronomer who passed away in June this year. I think it was June this year. And there'll be a 19-minute video that I'll play of that one. And of course, Tamitha, the space weather woman, has just released the latest report, and that goes for 15 minutes. So I'll squeeze that in too. So that should pretty much fill up the whole hour here without a problem. Anyway, just the usual blurb here before I continue on. The Astronomical Society of Victoria, founded in 1922, comprises over 1,800 members throughout Victoria, the other states of Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night. I think that's changed actually. Meetings start at 8 p.m. in the Mulia Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Meetings are also live streamed for those who cannot attend on the ASV YouTube channel and on the ASV's Facebook page. Parking is available in Burwood Avenue, Dallas Brooks Drive and the surrounding streets. Admission is free and visitors are most welcome. The general aim for those monthly meetings, is to start right on 8 o'clock. If there's going to be a presentation by anybody, that usually starts fairly soon in the evening, unless there's business to be taken care of first. And then the aim is for the person to, whoever's doing the presentation, to try and keep it within an hour, and basically for things to finish by 10 o'clock. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory, receipt of the ASV magazine Crux, containing articles, news, observing notes and the like, and free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. The 200mm refractor managed by the Royal Botanic Gardens and a recently restored photoheliograph are also housed at the observatory and are accessible to members too. The Society also has a number of 200mm reflectors available for short period loan under the telescope loan scheme. A member can gain practical experience in the use of one of these telescopes before deciding whether or not to buy for their own. Regular Society meetings are held at the Morley Community Village in Bentley East. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in how to use a telescope. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. It provides dark skies suitable for astrophotography. There is a range of instruments available for members to use, the larger two only with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is a 8.5 metre radio telescope, fully steerable, which members can access with involvement with the radio astronomy section. And a pleasant evening to any RAS members that may be listening. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the several common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for the various section directors can be found on the ASV's website. Further information may be obtained by visiting the ASV website at www.asv.org.au. That's www.asv.org.au. And once you become a member of the ASV, there's also regular email bulletins that are sent out every other week just to keep members abreast of what's coming up. And they call that the Crux Extra Bulletins. Crux Extra Bulletins are sent out to via email to members. Please note that the ASV will conform to all government health directives. Thus, ASV events may be required to be cancelled, moved or postponed. If you wish to write a letter to the ASV, the old traditional way of doing things, you would address the envelope to the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. And that's about it for that. All right, at 10 past the hour, this is the yearbook that we referred to, the Astronomical yearbook for 2025. It's quite a decent publication, and it smells lovely when you open it up. Oh, it used to at least. And yeah, so that you get that once you become a member. And the Crux magazine is a little thinner, but essentially that's what the magazine looks like. And there is a picture of Saturn with the rings on the side. So Saturn's beautiful ring plane crossing. There's the logo for wrong side for the Society. So this has been, the Crux has been in publication practically since the Society was founded. Probably not too long after 1922 they were producing a newsletter. It used to be called a newsletter, but now it's a magazine. All right, you're tuned to ASV Radio, VK3 Echo Kilo Hotel. I hope the streams hold in there tonight. My apologies in advance if any of the digital streams, i.e. the internet, my internet falls over. But basically the internet seems to hold in there while I'm actually doing the broadcast, and then when I finally take on the so-called callback, it's where it tends to fall over. So anyway, look, the streams look like they're holding in at the moment, which is pretty cool. All right. Now, I'm just debating whether to very briefly go over Tanya Hill's Sky Notes. Now Andrew says there's no audio on Discord. Let me just check that. 1, 2, 3, 4. No, there's audio there. I can tell that there's audio because there's a green border that occurs around my picture when I speak. So that tells me there is plenty of audio there. In fact, there's a bunch of people there too. It's a full-on house tonight. So g'day, there's Mitch, VK3ZT, Steve, VK3SPX, Stuart, VK3UAO, g'day Stuart. Our resident member of the Mount Burnett Observatory is there, David, VK3KDM, TJS Steve, and g'day Mike, VK3XL. It's a full house. So no, there should be audio there from what I can tell. You may need to just restart or reset something at your end there, Andrew. In fact, you're not there at the moment, but anyway, all right. So that's fine. Let me just check your email. Listening on 80 metres this evening, usual 5 and 9. Can't find the video feed on Discord. Only YouTube video available. Okay, well, I think I'm there. I think I'm definitely there on Discord, one way or another, from what I can see. All right, let me just have a quick look at Tanya Hill's notes for those that weren't around last week. In fact, I might if I'm going to try and squeeze in things, it's going to be a bit difficult, but let me see if I can summarize the notes. Let me just say that, what's the date today? It's the 7th of November. How quick this year is going, hey? All right, just from Tuesday, this is sunrise, sunset times. On Tuesday, the 11th of November, there will be the sunrise will be at 6:03 a.m., setting at 8:05. On Friday, the 21st, sunrise is at 5:55 a.m., setting at 8:16 p.m. And by the end of the month, on Sunday, the 30th, sunrise will be at 5:52 a.m., setting at 8:25 p.m. So our days are progressively getting longer. There was a full moon last night. There'll be a third quarter on Wednesday the 12th, a new moon on Thursday the 20th, and a first quarter on Friday the 28th, sorry. And of course they were talking about a super moon, although I don't think it was probably really defined as it, but anyway, the moon was closest to the Earth yesterday. I remember there being some article somewhere about the moon appearing fairly large, as it would normally when it's closest to the Earth. But yes, yesterday was the moon was at 356,833 kilometres, whereas on Thursday, the 20th of November, the moon will be at 406,691 kilometres. There it is. As far as a quick summary of the planets, Mercury, the planet closest to the Sun, is visible in the evening in the west from 8:30 p.m. until it sets in late twilight by 9:40. So if you haven't seen Mercury, the planet Mercury, before, thinking that it's because it's the closest planet to the Sun, so you can't see it, well, it's not true. Once the Sun sets, once the Sun goes below the horizon, there is a possibility to view Mercury. So Mercury is visible in the evening from 8:30 p.m. if there's a clear view of the western horizon. Venus, our sunward close neighbour, is too close to the Sun this month to be seen, but will return to our night skies in late April. Mars, the red planet, is not visible this month as it is about to enter a solar conjunction and move behind the Sun. Like Venus, it will reappear in April next year. Jupiter, the largest planet in our solar system, is bright and visible in the east from around 1 a.m. before fading in the north in the dawn's early light. And Saturn, this fainter but yellowish planet, is visible this month in the evening from 8:40 p.m. in the northeast, after which it will move across the northern sky, and before setting in the west by 3 a.m. It will appear as a little later each night as the month progresses. Meteors. There are 2 meteor showers that are occurring this month. There are the Taurids and the Leonids, which are with up to 10 to 15 meteors per hour if viewed from a dark location. The Taurids are bright, slow-moving with colourful fireballs, and occur in the first week of November in Taurus near the Pleiades star cluster, and also near the red star Aldebaran. The Leonids are high-speed meteors. They leave trains lasting several minutes. They appear in the constellation of Leo, which rises around 4 a.m. in the northeast from 30th to the 20th, but peak on the morning of the 18th. So if there's anybody out there that are interested in meteor scatter propagation or contacts via meteor scatter, that would be the morning to try and attempt some meteor scatter contacts on the 18th of November. Alrighto, and I think I'll leave it at that at this point in time. I don't think I finished all the what's the date today? The 7th. Just looking at the dates, the on this day listings. I didn't go through them all last week. I won't worry about it right now. Okay. Alright, what I'll do is I'll get into the main feature of tonight's article, because it'll take probably 5 minutes to read through this. But there is a video that I want to run as well, so I'm hoping that will play okay. In a nutshell, Sir Francis Graham Smith, radio astronomy pioneer, whose work indicated that the universe had a beginning. And I've got a picture of this fellow just here, if I can quickly find it. There it is. Sir Francis Graham Smith, former Astronomer Royal, who has died at the age of 102, was a pioneer of radio astronomy, carrying out research which helped to establish our modern picture of the universe. In the 1950s, he was the first astronomer to measure the accurate positions of distant radio galaxies, those that have large regions of radio emission that extend well beyond the visible structure. Together with Sir Martin Ryle, his predecessor as Astronomer Royal, he suggested that the speed at which these galaxies are moving away from us indicated that the universe must have had a definite beginning. These findings helped to demolish the then fashionable steady-state theory of Sir Fred Hoyle and others, which held that the universe had always existed. In the 1970s, Graham Smith did much detective work on pulsars, fast spinning stars made up of matter so dense that 1 ton can be contained in a teaspoon. And here's another image here, which is this one here. In this image here, you've got Graham Smith second from the left at the Mullard Radio Astronomy Observatory near Cambridge in 1961. And from left to right, there's Paul Scott, Martin Ryle, Robert Clark and Anthony Hewish. Yeah, in that image there. King Charles II, King Charles II established the Office of Astronomical Royal in 1674. Appointed in 1982, Graham Smith was the 13th to hold the office, an unlucky portent as it turned out, for the 1980s saw a series of cuts in funding for astronomical research. The shadow hanging over the British astronomy partly stemmed from a public relations disaster on the night of March the 13th, 1986, when, shortly after midnight, the European spacecraft Giotto passed through the tail of Halley Comet, sending back data to Earth. The BBC, in a late-night television show, invited several astronomers, including Graham Smith, to comment on the results, forgetting that none of these guests knew much about comets. The show was a shambles. No one could make a head nor tail of the Giotto data, but the real row began later in 10 Downing Street, where Margaret Thatcher was watching the program. She was angry at what she saw and decided that space research was a waste of money. The next year, she barred British participation in a European X-ray telescope searching for black holes and rejected plans to boost the budget for the National Space Centre, a move which prompted the resignation of its director, Roy Gibson. Caught in the crossfire, Graham Smith strove in as civilised a manner as possible to put the case for higher investment in British astronomical research. He says, "We have no shortage of excellent students," unquote, he observed in 1986, "but they will probably work abroad," he said. "The fact that we will go on populating the world with British astronomers is absolutely splendid, but wouldn't it be nicer to think that they just a few would stay at home," he says. Francis Graham Smith was born on April 25, 1923, to Claude and Cicely, I think that's how you pronounce that, Claude and Cicely, and educated at Epsom College and at Rosald School in Lancashire. He began studying natural sciences at Downing College, Cambridge, in 1941, but did not graduate until 1946. Like his colleague, Martin Ryle, he spent most of the Second World War working at the telecommunications research establishment at Malvern, involved in the development of radar. This experience led him into radio astronomy, and he stayed on at Cambridge after graduating to work with Ryle at the Cavendish Laboratory on radio waves from the Sun and other stars. By a fortunate coincidence, the largest sunspot for many years occurred at this time, in July 1946, and Cambridge radio astronomy grew from observations of its very powerful emissions. Soon afterwards, the pair were using the same techniques to detect radio waves coming from other parts of the sky. And one of the books written by Mr. Smith is pictured here, which is I've got one of these in my library. Caught in the... I think I've read that out already. Next, yes. Setting up a simple radio telescope in a field behind the house where they both lived, they left it for 24 hours to scan the sky as the Earth rotated, recording the radio signal on a paper chart recorder. When they looked at the chart the next morning, they were astonished to see the trace of not one, but two powerful radio sources in the recording. The radio source appeared to be coming from the constellation of Cassiopeia, A few years later, the radio source was precisely located and identified with the remains of a stellar explosion in the Milky Way. Another target for their research was a radio signal coming from a discrete source in the constellation of Cygnus. In 1952, Graham Smith located this radio signal known as the galaxy Cygnus A, the A indicating that it is the brightest light in its constellation, sufficiently accurately for a visual search to be made for a visible counterpart. And there's another book here too that's I've got a picture of. That's one book he did. This is another book he did. Back to the article. Oops. This search turned out to be, just making sure I haven't missed a paragraph here. No. This search turned out to be a turning point in modern astronomy. American researchers using large optical telescopes found that the radio waves were coming from a galaxy of unusual shape and with a large redshift, evidence that it is moving away from Earth at a speed which increases with distance. This discovery demonstrated that radio astronomy could be used for penetrating great distances outside our own galaxy. Cygnus A is the first known example of a radio telescope. And there's another book here. I don't have this one in my collection. I have to work on that. In 1952, Graham Smith went to America to work at the Carnegie Institute in Washington, returning to Cambridge in 1953. He published a paper with Ryle in 1957 suggesting that radio signals from orbiting satellites could be used to aid navigation. Throughout the 1960s and 1970s, Graham Smith worked on radio astronomy at Jodrell Bank, then moved into optical astronomy as director of the Royal Greenwich Observatory, where his main task was to build the new optical telescope at La Palma in the Canary Islands. In 1977, he was part of a team working at the British American Optical Telescope in New South Wales, which photographed the Vela pulsar, the brightest pulsar in the sky in terms of radio emissions. No more than 30 miles in diameter, yet weighing 1.5 times as much as the Sun. The star's total explosion, or supernova, had been recorded in the Sumerian inscriptions. In 1981, Graham Smith moved back to Manchester to become only the second director of Jodrell Bank, where he had a cameo in the series Treasure Hunt, giving Annika Rice a piggyback to help her reach a clue. He listed beekeeping among his recreationals in hoo-hoos and looked after the hives at Jodrell Bank. Right. In 1982, he was appointed Astronomer Royal, and he was Professor of Physics at Manchester from 1987 to 1990. After his retirement, Graham Smith, who was known as Graham to friends and colleagues, of course, became Vice President of the Royal Society, and his attention turned increasingly to the future of our own planet. In 1994, he hosted an international population summit, which concluded that zero population growth within the lifetime of our children was the only way to save the Earth from ecological disaster. Funny about that. He was knighted in 1986 and elected a Fellow of the Royal Society in 1970. He married in 1994 to Dorothy Palmer, whom he met when they were both working on radio astronomy with Martin Ryle in Cambridge. They had a daughter and 3 sons. Professor Sir Francis Graham Smith, born April 25, 1923, died in June 20, 2025 this year. Alright, now I have a little video to run, so let's just see if I can cue this up and hopefully it'll all work very well. It goes for about 19 minutes. It's actually a Patrick Moore video. He's on set. Francis Graham Smith was invited to talk to Patrick Moore, and this is an old Patrick Moore video from 1986. I managed to get this from a YouTube site, so the video is courtesy of Martin Mopley YouTube channel. So Martin is a very keen and fan of Patrick Moore. You might remember Patrick Moore's many of the videos that he used to do on the BBC. And anyway, I asked him, I sent him an email earlier on today, and he was quite happy for me to run this. So let's just see if we can play this, and hopefully it'll go okay. This is VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. And let's see if we can, I better put my headphones on so I make sure the audio is okay on 80 metres. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, stand by.
I'd like you to look at that dot on the end of the arrow in this photograph, which is, of course, a negative. That dot looks like a star, but it's not a star. It's something very much more dramatic. It's what we call a quasar, and it's shining as brightly as hundreds of whole galaxies put together. Good evening. Actually, we've known about quasars since 1963, because many of them are very powerful radio sources, and they can be studied, therefore, by means of radio telescopes. And the most famous radio telescope in the world is still the great 250-foot dish at Jodrell Bank in Cheshire. But it soon became clear that quasars really were absolutely incredible. And for one thing, they were immensely luminous. Now, a galaxy, such as our own, contains roughly 100,000 million stars. And can you just imagine, therefore, the combined luminosity of hundreds of those systems put together? But that is a quasar, all contained inside an area which is relatively small, no bigger than, or about the size of the solar system at most. So what can cause it? All kinds of rather strange theories came to light. One was that the quasar power might be due to chains of exploding stars going off one after the other. But that didn't seem to work. There was no reason for it. Then what about that curious thing, antimatter? That didn't seem to work either. And then, could quasars be powered by vast black holes? Well, that was a bit better, but it still didn't seem to be the true answer. And also, it became clear that quasars are racing away very quickly. Now, we know that the entire universe is in a state of expansion. And once you get beyond our own local group of galaxies, then all the galaxies are racing away from us, and the further away they are, the faster they're going. But quasars are much more luminous than normal galaxies, and therefore we can see them out to greater distances. And we know they're receding, and we know the rate at which they're receding, because of what is called the red shift. Light is a wave motion. When you look at the spectrum of a star, or that of a galaxy, which of course is a jumble of many millions of stars, or for that matter an ordinary quasar, what you see is a rainbow background crossed by dark lines, and each one of those dark lines is characteristic of one particular element or group of elements. Now, if the object is moving away from you, then fewer light waves per second enter your eye than would be the case if the object were standing still. So the wavelength is effectively lengthened, and the object appears a little bit too red. Now, you can't normally notice any color change, it's too bright, but it does show up in the spectrum, and all the lines are shifted over to the long wave or red end of the spectrum. And the more the lines are red shifted, then the faster the thing is going away. And that's how we can tell that the universe is expanding, and that does apply to the quasars. And, as I've said, the further away they are, the faster they're going, and clearly we aim to see out to great depths. And quasars give us the best chance of doing that because they are so luminous. For a long time, the record was held by a quasar called OQ172. And there it is, again, the little dot on the end of the arrow. And that seems to be something like 10,000 million light years away at least. But it's no longer the holder of the distance record. After a long search, a more remote quasar was discovered, and this came to light at the Parkes Radio Astronomy Observatory in New South Wales. And there's the great 210-foot dish at Parkes. They discovered a quasar, which appeared to be a very long way away, and they contacted the optical astronomers at the Siding Spring Observatory, not very many miles away, and there the great Anglo-Australian telescope was used to identify this quasar optically. And here it is. We call it PKS 2000-330. And that has a redshift indicating that it's going away from us at something like 90% of the speed of light, and that works out at a distance of, well, shall we say 13,000 million light years, in which case we are seeing it not as it is now, but as it used to be 13,000 million years ago. But if the rule of the further, the faster holds good, then you are going to come to a distance at which an object, be it galaxy or quasar, is moving away at the actual speed of light, which is 186,000 miles a second. And of course, in that case, you won't be able to see it at all, and we will have got to the boundary of the observable universe, though not necessarily that of the universe itself. And that's what we very much want to do. We want to look out to great depths. And now there's been a most exciting discovery, a quasar which is further away than any previously known. And it was discovered with the aid of plates taken with the UK Schmidt telescope, also at Siding Spring. It's very faint. It's in the southern part of the sky, in the constellation of Sculptor, and it appears to be definitely further away than the previous record holder. Well, to tell us more about quasars, who better than one of the world's greatest radio astronomers, who also happens to be Astronomer Royal, Professor Sir Francis Graham-Smith. Graham, welcome back to the Sky at Night. First, how was this discovery made?
You have to realize that to sort out a quasar from all the stars and galaxies that are in the sky is like looking for a needle in a haystack. If you take a photograph with any telescope, you see a lot of stars and you see a lot of galaxies and you see some quasars, and they really all look very much alike. A new technique's been developed by astronomers at Cambridge, in particular Stephen Warren and Paul Hewitt, who have been able to sort out the needle from the haystack. They've used the Schmidt telescope again, and they've used a means of analysing the plates from it. They use a machine called the automatic plate measurer at Cambridge. And in this way, they can look at many objects, for example, 30,000 objects or so on one of those Schmidt plates, and decide which ones are likely candidates for quasars. They do this actually by taking 5 plates of each area of the sky, using different colour filters, and they're looking at the colour characteristics of the quasar.
So in point of fact, this new discovery was made optically, but all the early quasar work was done by means of radio astronomy, wasn't it?
Yes, that's right. The previous record holder, PKS 2000, that was discovered as a radio object, and the radio astronomers told the optical astronomers where to look. Now we haven't got that help, and the interesting thing is that the radio used to sort out these objects quite easily because they stood out, and they don't stand out optically. However, we do know there are at least as many radio-quiet optical quasars as the ones we would have picked out by the radio. Well, how are you going to pick them out? That's the real problem.
Yes.
You see, you've got a plate from the Schmidt telescope, which is like this, an enormous thing. It's covered with dots. If we look at a print from this, then we can see the myriads of images on it. And the closer you look, the more you see. And they're all just little dots, nearly all of them are, and it's very hard just from one plate, impossible from one plate, to find out if they have, say, a different colour. What really matters is that the quasars do have different colour of light. They have a different spectrum. If we go back to your PKS 2000 again and have a look at that, you can see that the image on any one plate looks like, well, any star image. But if you can put that light into a big spectrograph on a big telescope, like the Anglo-Australian telescope, you see a spectrum spread out like this, which is very characteristic of a quasar. Look at that very prominent spectral line in the middle. That actually comes from hydrogen, and it was emitted at a wavelength which is 1/5 of the wavelength we're now receiving it. And that means that the familiar spectral lines in the optical spectrum have been moved right out into the red end of the spectrum. So the way of recognizing quasars is to recognize them by their spectrum by taking these 5 colored photographs and using this new automatic machine and the new technique which has been developed by Stephen Warren and Paul Hewitt.
Well, if the red shifts in the spectra are reliable as distance guides, and there's no reason to suppose they aren't, then we are talking about something that may be 13,000 million light years away. In other words, we're seeing it as it used to be 13,000 million years ago.
Yes, that's right. I think it's quite a good idea to talk about ages, and particularly to talk about ages in relation to the age of the universe. And we're actually looking 9/10 of the way back to the time when the universe began. That might perhaps best be shown on this clock face. But what we have here is a clock face which is 12 hours, but the 12-hour clock face is meant to represent the whole age of the universe. It means that the span of human existence is going to be a minute amount, the odd second. But we're going to turn the clock back now and see if we can see how the quasar fits in with the time scale of the universe. Now what we're doing, we're going back to the time when life began on Earth, which is at about 1/3 of the age of the universe. Here we are. During that time, you've got the geological record of life on Earth. Before that time, you have to turn to the quasars and the galaxies. If you want to go to about half the age of the universe, you can do that with ordinary galaxies and some of the quasars with not too much difficulty. What we've got now is quasars which will take us back all the way to the time when the universe was 1/10 of its present age. Here we go, working our way all the way back to 1/10 of the age of the universe. That's it. And that is why this is so important. The astronomy that we're doing is studying the universe when it was very young.
And of course, this kind of work is where optical astronomy and radio astronomy really come together.
Well, they do. It's really a very interesting thing. The optical astronomy can get the redshift and the details of that spectrum. But radio astronomy can give you a map. Now, looking on an optical photograph, like the PKS 2000 we showed you, you just see a little dot, nothing more. Radio, surprisingly, can give you some details, a detailed picture of the quasar. In fact, it's a picture of the radio emission that's coming from it. Look at this object. This is a quasar. It's actually a rather nearby one, 3C273. The object at the top left there is what you see in an optical telescope, a bright dot. But sticking out from it is this jet-like object. In fact, it is a jet. It's been ejected from the quasar itself. It's very energetic gas. It's emitting radio waves, and this is actually a map of the radio emission from the quasar. And we are making maps of this and beginning to understand not only why it's radiating, but where the energy originates to send this jet out, and then also what happens when the jet of material hits the gas in the galaxy and churns around, creates magnetic field, high energy particles, and you get that radiation. Now this is obviously very valuable, but it's not obvious at first sight how you can draw a map of such detail in the radio domain when you can't do it in the optical domain. Now, there's a general rule that the more detail you have on the map, the bigger the telescope you need to do it. It's fairly obvious. But in the radio domain, that means something very much bigger than the Mark I telescope, which we've already seen in this program, familiar thing. You need a telescope which isn't like 100 meters across, but 100 kilometers across. Well, strangely enough, we can do that now. If we look at what we're doing at Jodrell Bank these days, we actually have a network of radio telescopes which covers the country. There's one recently added to them which is as far away as Cambridge, and that's 200 kilometers away. All those telescopes are connected back to Jodrell Bank by microwave links, and they all work together in a network which we call Merlin, Multi-Element Radio Linked Interferometer Network, Merlin. And that actually creates for us a telescope which is 100 or 200 kilometers across and enables us to draw these very accurate maps. Some of the detail we need in the maps needs an even larger telescope. And for that, we connect ourselves up to other radio telescopes overseas. There's one in America called the Very Large Array, for example. And we find ourselves cooperating with people from other countries to put these maps together. In particular, we've recently been collaborating with some Canadian colleagues, Anne Gower is one of them, and drawing a map of a very distant quasar, and this is in fact the map that we've recently drawn, a very exciting object. Again, the optical picture would just show one bright blob, as it happens the one in the middle of this picture. But the radio emission comes from these jets which have been shot out from it, and there's one down at the bottom and a very interesting one at the top of the picture. The jet is showing a curious shape, which is rather like a jet of water hitting something and spewing around as it does so. So we're looking at the physical interaction of a quasar with its surroundings.
We've learned a great deal about quasars now, but what exactly is the energy source? What produces this tremendous amount of radiation?
It's something to do with the concentration of material at the center of the galaxy, and this seems to happen more in galaxies near the early stages of the universe. There must be a massive concentration either of many stars or of an actual black hole, and this is attracting material, stars, to fall in, and as they fall in they release energy. We see the release of energy as a jet or two jets which spew out along perhaps a rotation axis. The optical pictures show the excitation of the gas around, very hot gas and so on, but we're fairly sure it's basically gravitational energy. We'd like to know more about that, an interesting source of energy, and we'd also like to know the physical conditions around it a little bit more detail.
We've now probed out further than ever before, and we've come to this new quasar with what they call a Z value of 4.01. But what exactly is Z? What does it mean?
Well, Z's a measurement of distance, in fact, although we measure it as a change of wavelength of the light which is received. Well, to start off with, close by Z equals 0, because there is no redshift. But if we go to Z equals 1, for example, that's not very far away. That's where the wavelength has been stretched actually to double its original value. So here's a spectrum of light at Z equals 1, still in the optical range of wavelengths. If you go a bit further to Z equals 2, there are galaxies with Z equals 2, then you can see the light is stretched towards the red end, and in fact there's less light in the optical range. Z equals 3 takes it even further. The light is now moving out from the optical range into the red end, and Z equals 4, where we've recently got to, you can see that the light, a very large part of it, has moved out of the optical range, which of course makes it much more difficult to detect the quasar. It's weak because it's a long way away. The light has moved out of the optical range and made it much more difficult to detect. So this is actually quite an achievement to get to Z equals 4.
How much further can we go?
Well, Z equals 4 is a kind of a boundary which people thought we would never get past. It's rather like the 4-minute mile to get to Z equals 4, and 4.01 is a real achievement. I think it's very likely that we shall get to Z equals 5. Beyond that, the technique probably gives up, and I think the Cambridge people are hoping to get to Z equals 5 and probably open a big bottle of champagne when they do.
I'm sure they will. After all, I think it's generally agreed that the limit where an object's receding at the speed of light is somewhere between 15,000 million and 20,000 million light years. Are we anywhere near that limit now, you think?
Well, we're about 9/10 towards it, but we may not get very much further. The problem is that, well, there are two problems. First, it's more and more difficult to find and detect and measure the quasars. Second, there may not be any beyond there, because we are certainly reaching a point in the universe where things are different from the local universe. And it may not be worthwhile looking for more quasars further away. There just may not be any.
I wonder if there are. Meanwhile, this new discovery was made optically, and I gather that this very distant quasar is not yet showing any signs of being a radio source, which is interesting.
Well, that's true. We are, in fact, I can let you into a secret, having a good look at it right now at Jodrell Bank with a very sensitive interferometer, and it is quite certain it is a very radio-weak quasar if it's detectable at all.
I wonder. On the whole, what do you think is the greatest significance of this new discovery?
I think the significance is the cosmological significance. There is of course, the excitement of the physics of what's going on, the heavy mass and so forth. But what about the history of the universe when we are at last seeing beyond what we might call the local universe into a time which was rather near the origin of the universe, when we can see the galaxies forming. There was a time, obviously, when the universe was entirely uniform. That time passed shortly before this galaxy was radiating to us. And now we can see a time when the galaxies, the stars, the quasars were forming. And that's exciting to get into the history of the universe.
It most certainly is, Graham. Thank you very much. And isn't it satisfying, too, that so much of this research is due to British astronomers? Not only Jodrell Bank and Merlin have the Australian telescope, the Canadian telescopes, and so on. And, you know, it really is quite breathtaking to reflect that when you look at that tiny dot on the picture, we are seeing something not as it is now, but as it used to be when the universe was very, very young. Good night.
Well, there we are. Oh, Struth. Caught out. I was watching on the ATV repeater. Ah, dear. Anyway, Francis Graham Smith, dead at 102 years of age, June 25 this year. And quite a remarkable life he's no doubt had. Yes. I've got a few of his books, but the ones that I've brought down out of my library is this guy here. This is probably one of the first radio astronomy books that was actually given to me. And it's a wealth of knowledge, but that's one of the books that I've got. And the other one here is an introduction to radio astronomy, 3rd edition. Again, Graham Smith there, and it's quite a decent publication as well. It's just a couple of books out of my massive library on radio astronomy books that I've got. Anyway, all right. Now I think my audio levels should be okay. Looks like it's a little high there on vMix. I might just knock that down a bit. 1, 2, 3, 4, 5. All right, let's get into. Hang on a sec. Just turn that off. I can see what was going wrong there. Damn, mate, I've got to fix that up. All right, let's go across to Tamitha Scove. This will be going a little bit over time, I'm sorry to say, ladies and gents, but it's worth listening to Tamitha with the latest report, which only came out just a few hours ago. So stand by. Let me cue up dear old Tamitha. Where is she? There she is. And away we go with Tamitha's latest report.
We have a whole train of solar storms, and some of them are on their way to Earth, with some fast solar wind clearing the way, plus big X flares and a whole host of regions on the sun's far side that'll keep us storming. Wow, what a week, and it's just getting started. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week picks up in a big way. As we take a look at our Earth-facing disk, all eyes are on the east limb with regions 42, 72, 74, and 75. Now these regions, believe it or not, starting around the 2nd, started firing off these very large solar storms, and you can start seeing them here in coronagraphs. You start seeing partial halos. You can see there's the first storm, almost a partial halo. Here's a second one. You can kind of see a very dim halo right here. Then here's storm number 3, not quite so much. And then here's the big one. This is storm number 4. This one is the one that is most Earth directed. We'll talk more about this in a minute. Plus, we've got one more And that's just getting started. These regions are still reasonably on the east side of the sun, so they could be giving us big storms over this next week that we haven't even seen yet. So this is just the beginning. Now, why is all this happening? Why are we seeing so many of these storms? Well, the reason why is that, believe it or not, this area is very magnetically complicated. We have this big coronal hole here that's going to be giving us some strong, fast solar wind here in the next couple days. And this fast wind is kind of clearing the way. But it's also part of the coronal streamer belt because we've got an area that's like really highly tilted and the thing bends super sharply, as I'll show in a minute. So it reveals that this area is extremely magnetically complex, and that's likely going to continue causing those regions to fire and fire and fire as they rotate across the disk. As we take a look at our potential field source surface model, you can barely see that coronal hole right there, but that's where that fast solar wind is. And you can also see these overlying loops. This is kind of what I'm talking about with the coronal streamer belt being really highly tilted. But look at this. Look how much it tilts and bends right here, right in this little nook and cranny where these regions are. This is highly unstable. And so we've got a lot of magnetic reconfiguration in that region, and it's going to continue. In fact, all of these regions, as they continue firing, are very sympathetic to one another, that one fires and another one goes. And we'll look more at that in a minute. Plus, we've got some more sympathetic connection to this region here. This is region 4276, and it's going to be firing. It already has been firing quite a bit on the far side. Here's region 4272. Talk about sympathetic eruptions. This is part of one that's coming toward Earth as well. And as we look at these a little bit more closely, especially some of these regions in here, we start seeing why these the solar storms have already been hitting Earth a bit more than the models anticipate. And it's because if you can look in here, you can see these really dense core filaments. Do you see the dark lines in here? And right here too in region 4275. This is 4272, or excuse me, yeah, 4272, 4274, and 4275. And the new one, 4276, is down there. So you can see these core filaments lighting up. And when we get that, we get really strong, dense solar storms. You can also see the sympathetic, the synergistic connection between these regions. So this is going to continue to happen. It's all because we've got that curved magnetic field in here, and so it makes this region extremely complex. And as we take a look at these in the magnetograms in HMI, you can see the different colors mean different magnetic polarities. And when they get really mixed like that, that's not a good sign. In fact, that core filament that we're talking about right here, that kind of launched solar storms kind of in the plane of this, in the ecliptic plane, pointing kind of like this way, their axis is elongated like this. You can actually see that mapping out in here. This is the area where that core filament is overlying. And you can watch, you can actually see these magnetic loops light up with some of these big flares. See all these loops? It looks almost like a little mini slinky being kind of embedded in this. So these are the solar storms that are being launched, and they're elongated in such a way as they're going to give Earth a really good show here over the next few days and possibly longer. So everyone get ready for this because this could be some amazing shows. Here's the next one in the storm. This one actually launched a halo, a partial halo that's kind of going north of Earth, but we'll probably get a glancing blow from that as well. So get ready because things could get pretty exciting for aurora photographers in through the end of this week and possibly into next week as well. And now as we switch to our sun's far side, we're taking a look at stereo A imagery because stereo A is staring at the far side of the sun just beyond the west limb. In fact, you can see here's Earth, here's the sun, and here's stereo A staring at the sun a bit from the side. This is the coronal hole that gave us some fast solar wind about a week ago. But what I really want you to see is this region right here. Look how quickly this region is growing. This region is one of several that's been growing on the sun's far side. It could definitely become a big flare player here over the next few days. And by the time it rotates back into Earth view in about 10 days, this one could be part of this ongoing big flare activity we've seen. It looks like we're probably getting a bit of a Rossby surge, and we'll talk more about that as we flip to our full sun map here in just a moment. Here we go. Now we're in the full sun map, and as what we're looking at are three different types of data. First, we've got SDO AIA imagery in red here. This is the Earth side of the sun. This is what we're seeing. We've got green. This is stereo A imagery, just like we saw before. We have our orbit circle, so you can see a bit what that stereo A is seeing, a bit of the far side that we don't see beyond our west limb. And then to fill in the gap here, we're using HMI helioseismology far-sighted viewer so that you can see the regions on the far side, because we don't have right now any spacecraft on the far side of the sun. So as I set this in motion, you can see region 4246, which became 4272. You'll see that. So this should get you oriented. So here are the big flare players right now. And so you saw them on the far side as big, dark regions, right? So here we go. We have this region is 4275 as it rotates into view. This is the one that has just now become 4276. But look back here. You've got another region here. You've got another region here. And there's that region that we were watching growing in stereo's view. So we're getting kind of a train of maybe big flare players on the far side that could give us a kind of just a continual pulse of these big flare shows over this next week, possibly 2 weeks before things finally calm down. So get ready, folks. Not only will we have big solar flares on the day side of Earth, but we also could have big solar storms here, possibly continuing over this next week and maybe even longer. And now switching back to those Earth-directed solar storms, we flip to our solar storm prediction model, ENLIL. Now this is NOAA's version of the model. The top panel's density, the bottom panel's velocity. You're looking down at the north pole for the sun, and Earth is off to the right. Now as I set this solar storm model in motion, what you will see is a train of solar storms coming out. There's the first one there. You're going to see a second one. Here's the one right here. I'm going to pause it for just a moment. You're going to see that. That's the one that we really think is going to hit Earth. And then there's one after that as well. This is the one that is mainly going north of Earth. Now, strangely enough, in this train, it looks like they're going to completely miss us, but we have been getting hit by a solar storm over the last 24 hours that has bumped us up actually for a moment up to G3 levels. It didn't last long, so it's not that big a deal, but it sure is giving Earth some preconditioning. So why in the world are we missing this with some of these models? It's not because this solar storm hit early. I think it's because these storms are actually a little bit more Earth directed than we believe. So as we take a look at this one that's going to hit Earth right here, you can see NOAA's expecting the impact to be basically early on the 7th, maybe even late into on the 6th. But likely the big storming isn't going to happen until we get into about the 7th. And now let's replay that ENLIL model with the benefit of our 3D solar storm visualizer. And we're going to focus on this big solar storm here that is headed toward Earth and get a better idea as to why some of these earlier solar storms actually are grazing Earth when we hadn't expected them to. So as we play this out, you can see here's the lemniscate right here. This is the gold cone. This is what both NASA and NOAA use to actually put into the ENLIL model to get the puff of a solar storm. But I've overlaid a flux rope structure on this, and I'll tell you why. It has to do with the way the coronagraph images look in with this overlaid on them. That kind of helps give an idea as to the tilt of these structures. So as we flip to our 3D model now we can actually rotate this object in 3 dimensions and get a better feel for what this structure looks like. As we align it with stereo's view, you can overlay the coronagraph imagery and see why this flux rope is actually aligned along that way. It means it's a low inclination flux rope. That means its legs are stretching way out to the side. Now, as we have this blow out over Earth, we zoom in and let this blow out over Earth. You can see Earth right there. And now let's take this and rotate it so that Earth is kind of rotating here and align it with the sun. So now Earth is aligned with the sun essentially, and you can see the tilt of this structure. If we overlay a coronagraph image there, you can see again, this is explaining a bit more why we're seeing these structures extending out further than the lemniscate really would let us believe. I've actually tilted this lemniscate a little bit more toward Earth than the original fit, but you can see that shockwave blowing out, and that's because of this boundary of the flux rope. Is the legs are really sticking out far. So as we continue to play this, and you can watch this structure move out over Earth, you can see we may not hit the core slinky of this structure, but we sure are going to hit that envelope. And that means if we get more solar storms that are oriented in a similar fashion, expect them to be more and more Earth directed, expect the storms to last longer, and that means more aurora easily over the rest of this weekend into next week. And if more storms are launched, well, we could be storming for even longer. And now switching to our moon, we are now passing through the full moon phase on our way to a third quarter. And by the 12th, the moon will be still about 47% illuminated. So you night sky watchers, if you want to catch the dim objects in the sky like aurora and even some meteors, well, you're going to have this bright companion. So you're going to need to check your local rise and set times. And now switching to our solar storm conditions and aurora possibilities over the coming week, we are expecting a lot of storming here over the next week. In fact, at high latitudes, NOAA is expecting severe storm conditions with up to about a G3, in fact, about a 65% chance of the severe storming. And this will continue easily in through the 9th, possibly in through the 10th before things begin to calm down. So aurora photographers, hey, if you're at high latitudes, you're going to get a lot of show, especially with some fast wind that's going to be chasing this. Now, at mid-latitudes, well, we are expecting major storm conditions. By the 7th, we should be getting our peak, at least right now. But of course, this solar storm forecast could change very quickly because we do have these active flare players, and they could be launching more storms as we speak. So expect about a 20% chance of a severe storm, and then things calming down as we get through the 9th and in the 10th. But again, way out there, the forecast could change very quickly. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we are sitting in the mid 150s or so with solar flux rising. We do have severe noise on the dayside radio bands. In fact, NOAA is expecting about a 70% chance of R1 to R2 level radio blackouts and about a 25% chance of X-class flares. I've stretched this out and even increased it a little bit as we move into the early part of next week because we have other big flare players on the far side that are going to be rotating into Earth view. So amateur radio operators, emergency responders, and aviators expect a lot of noise on the bands. Radio blackouts are on the menu, even at the R3 level. And now switching to our radiation storm and polar aviation outlook over the coming week, we're sitting in the D2 minor range right now. This is at flight level 360 for you aviators. It's also the elevated level, but it's only S0 right now. We're not officially in a radiation storm. We just have elevated levels. NOAA's giving us about a 25% chance of high radiation at an S1 to S2 level. So you high-risk passengers and you aviators and flight crew, be aware, check those ICAO advisories and plan for these types of elevated radiation conditions in your flight plans, because this is likely going to continue over the rest of this week. So the space weather this week is very exciting. We have a train of solar storms that are on their way to Earth. Some of them have already been hitting Earth, giving us glancing blows, but we should be peaking right around the 7th. Aurora photographers at high latitudes, you're definitely going to get a show. Even aurora photographers at mid-latitudes, you're going to get a show. And the show may easily continue in through the 9th, 10th, and possibly longer because these big flare players are still launching solar storms, and they're about to rotate into the Earth strike zone. Now, amateur radio operators and emergency responders, things aren't looking too good for you. We've got the big X flares with radio blackouts at the R3 level, and we got big solar storms on the night side and the severe side. So guess what? Signal propagation pretty much all over the globe is not going to be so great for you. So just kind of hunker down and let's see if we can get through this week. And now you GPS users, well, same kind of thing. We've got issues both on the day side and the night side. So your GPS reception, especially near dawn and dusk, especially near aurora, is not going to be too trustworthy, so be very vigilant. And if you're a drone flyer, please be sure to calibrate your magnetometers often when you fly. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Thank you, Tamitha. All right. Now we've gone a little over time, so where's my other camera here? What I favour the most. There we go. Okay, it's a bit better. All right. Thank you, Tamitha. Okay, now we've gone over time, so considering that was pretty much detailing of the solar weather, I won't really go into the spaceweather.com. It'll take another 5 minutes, but I will show you the latest solar cycle. So for those watching the TV video side of things, the top is the solar cycle, and the bottom graph is the radio flux, solar flux, and you can see how they mirror each other. So the peak of the solar system is pretty much come and gone, and we're now heading down the slope. But still, the sun is very active, as Tamitha has just said, and these next few days we're definitely going to be having some blackouts. So I think if you're keen on HF operation, you'll probably see some of the bands being very, very quiet. Like 40 metres has been particularly quiet at odd times over the last few weeks, so that'll continue to occur. All right, I had a number of other quick articles, but I'll leave those till to next week. Yeah, we're over time. So this is you've been listening to VK3 EKH, VK3 Echo Kilo Hotel, which is the official station for the Astronomical Society of Victoria, regular Friday night broadcast, and we'll now go across to 3541 for any stations that might wish to that are still hanging around, wishing to check in. If I can find a pen that's going to work here for me. Yep, that'll do. Just remove these headphones and let's see if we can hear any stations. This is VK3 EKH listening 3541.
VK3 GL. VK3 Tango Juliet Sierra.
Okay, acknowledging VK3GL and VK3 Tango Juliet Sierra. Any other stations? Band must be too noisy. And just acknowledging the stations that we're on, the Discord. Andrew, VK3KIS, Mitch, VK3ZT, Steve, VK3SBX, and David, VK3KDM, and of course Jack, VK3TJS. Mike was there, VK3XL. Cheers to you there, Mike. So that's the Discord group. We've only had one email that's come through, or two really, from Andrew there. So that's just a quick report there. I'm not sure how many YouTube channel people are watching on YouTube, but I'm sure there are some that will probably catch up with this broadcast throughout the next couple of days. There always seems to be about 20 people that catch up with the broadcast. All right, Graham, VK3GL in Bunyip, have a say, VK3EKH.
Yeah, okay, good evening there, Clint, VK3EKH, VK3GL in Bunyip. An unusual check-in tonight. I've been working here in the shack and just listening to the broadcast, probably for about the last half hour or so, I do say, Clint, and pretty much good signal all the way, being 20 to 30 and sometimes peaking 40 over 9, so really ripped the signal here on 80 metres tonight despite the atmospheric conditions being thrown at us from the sun. I'm running what was a very, very sick old TS120S, which I picked up probably 4 or 5 years ago for next to nothing, and I finally had an opportunity to try and work on it. I had another one that I was fixing, and I thought I'll get mine out and fix it at the same time. So I hope it sounds okay from all the testing and line-up and everything that I've done on it. It should actually be sounding not too bad at all. Had a crook receiver and a few other bits and pieces. Anyway, I won't go into all of that. It did take a bit of time to sort it out. But still a little bit more to do on it and try and get the VFO to a bit more stable. It's okay after about a half an hour warm-up or so. It seems to be relatively stable then. Yeah, all good on the broadcast, and I was listening to Tamitha's reports with some giving interest. I know that there'd been a couple of flares a couple of days ago, and that knocked the guts out of 10 metres. and as you know, I sort of, because I'm fixing radios and that a bit here, I've usually got an 11 metre radio going and monitoring the propagation. And even that's been hit and miss and a bit strange. So much so that last night when I was driving home from Frankston, which was relatively late, I happened to be listening on 11 metres where there was a bit of activity, and there was some late night conditions operating last night, and while I was mobile for approximately half an hour, I was listening to a guy on short skip from the Grampians, and he was about S9 the whole time. There was some very, very quick fades, but then it kicked up equally as quick again. And another station broke in, and he was in Shepparton. So I'm mobile east of Melbourne on the freeway, listening to a guy in Shepparton, a guy talking, all of these guys are talking to a fella in Cranbourne, and yeah, so I thought that was quite unusual, and obviously probably a legacy of the solar activity. Today's been pretty dead. Now, I also have been having a look at the aurora forecasts, and particularly in the northern hemisphere, that's at storm level, and I've had a look at some of the photographs that have been taken in the last 24 hours, and even live this evening. There's been some fantastic photographs taken up on the northern hemisphere, so I'm hoping in another 4 to 6 weeks' time that we'll have similar conditions. We probably won't be travelling up the coast of Norway until about the 10th or 11th of January. That's sort of when we start that, so we'll be keeping a keen eye on all of the predictions anyway to see what we might be able to see, that's for sure. Anyway, there we go. Put it back to you there, Clint. And look, there may have been a little bit of drift on this over, but it is something that I need to attend to on this old 120S. But considering it's now going, I think that's well, a relatively fine achievement, because it was a pretty sick puppy, that's for sure. VK3EKH, VK3GL.
Yeah, righto. VK3 Golf Lima in Bunyip, VK3 EKH, VK3CSJ on the microphone. Well, you're averaging about 30 over 9, 30 over 9 here, so it's a good strong signal. The audio quality is a little harsh. It's not distorted or anything like that. It's communication quality. It's very peaky in the 2.5-3K region. So it's all the bandwidth energy is concentrated in the upper part of the audio spectrum there. It's very communication quality, ideal for calling CQDX and to be heard amongst dog piles. It's that sort of sound. So, but it's it's okay. It's certainly not hi-fi. But it's sounding all right, but definitely on that very peaky sound. I don't know whether you're watching any of the videos, Discord or YouTube, but it looks like my stream is still running. I half expected the stream to fall over by now, but it looks like I'm still streaming to YouTube. So if you want to check out your audio, just go back to this moment in the YouTube side of things, so you can have a listen to yourself. I've got a direct patch. There's a combination of direct patch to the system and what the microphone's picking up, so you'll have to work it out for yourself. Anyway, yeah, look, there's certainly going to be. Look, I think you've got every opportunity to be able to see the aurora up there in the northern part of Europe when you head that way. Pay attention to the websites that broadcast that information, particularly things like spaceweather.com. Keep an eye on spaceweather.com because they'll always keep you abreast of what's happening. Again, I'm not sure if you're watching the video, but this is the current auroral oval over Antarctica as I speak. It's only a greenish colour at the moment, so it's only about 40-50% there. If you were down at the south end of Tasmania, you might see a bit of a glow on the horizon. But it's But anyway, there it is. All right, no worries, Greg. Good to hear you. Thanks for coming up. Since you've retired, we don't hear you too much on the Friday night broadcasting callback, so it's good to hear you. Okay, on the radio anyway, the TS120S. So it's definitely working. There's been no drift that I can detect. It's been pretty well on frequency during that whole over, so it's quite stable. But like I say, the audio is very crisp, which is, like I said, it's communication quality, and okay for that, but just a little on the harsh side compared to your other transceivers that you do use. Anyway, all right, thanks, Greg. Across to Jack up there in Shepparton, VK3TJS, VK3EKH.
VK3EKH, this is VK3TJS, and of course the group is never to let it pass give it of course, and trying on new ones from time to time, and the old ones as well. So I'm transmitter that newly acquired moment, VK757GS, so the one on. Look, thanks for the broadcast all the way from Helva in Shepparton, despite all the crashes and everything. Earlier in the night there was some crashes to the point that we've cut short the troubleshot net and nothing to that. The Aurora TNS reports from Poland, Aurora has been doing some common occurrence there, but it's not. I'm sure that's it. Norway, we're very common over that. Another interesting thing, we've had a warning yesterday, birds hitting the fire lines on trees from us, but next one to us, and this robot recorded. And the birds set on the 22 kV line and touch the earthing, and that's what happened to the last the birds slow down and then for the next 29 hours we have no power, and for the evening off, next day and so on, and eventually in the morning I kind of rustled up and when I say generated to kind of run the frequency of coalition trees up from the next 45 we go house by house, checking everything that happened. So yeah, you mentioned 29 hours for I'll be there, no nothing. Breakfast work and dinner work and stuff and home. So that's my the best story here. Thanks for the broadcast again, please, and hope you have a good weekend. Enjoy it. Catch up next time. VK3KH, this is VK3TJ. Over.
Yeah, okay, Jake. VK3TJS, VK3EKH returning. Just a little tricky to hear you during that over, Jake. You started out okay, The lightning crashes were a little bit strong, but your audio seemed to fade down. Maybe just backed off the microphone a little bit, because just in that last 30 seconds as you're about to put it over to me, your signal picked up